Okay, so in the first part of this tutorial I was going through all the different steps, but I forgot to actually do the blind measurements. So here, just to show you again, you see the result. This is all produced from the GUI. This test example was the name of my save file, so you see there's a HTML file, some profile data, and some JPEGs, and also some KMZ files. But I want to, in this GUI, just briefly explain again this blind measurement step. So I go through all the steps again, but it will show you how this blind measurement works and what it's doing. So just select it for now, and then again load the DEM. So I will pretty quickly go through this now. You can actually also use another feature for plotting since I'm on it. So this is again Hillshade, but let's see. There's also this openness. It's another feature that's also described in this 2015 paper, kind of a curvature measure. It can be helpful depending on the exact data set you're looking at. Let's see. Okay. Yeah. Okay, now tracing the blue feature as well. I'm not trying to be super precise here, it's not necessary really for this purpose of the tutorial. So, okay. So remember, if you look now here, the traced value, the one I had before was, I think, in the 21.6 meter range. Now it's a different value, quite a bit different actually. And that's because this blind measurement approach puts a randomized scaling factor in front of the actual measurement, in front of the correct values. So this hides the true values from you. So now I have to go through the rest of the steps. Okay. Okay, so you can see different values here too. So for the offset calculation, you have to basically assume that this is the correct value and correspondingly enter values that bracket this one that you defined over there, up there. So let's see. Here we get our displacement now. So the code, because it's randomized, thinks now that because of the blind measurement, that our best offset is about 28.5 meters, as it is said right here, and 1.4 meters in vertical, that first value being horizontal. So we can then again do this here for the backslip, for this offset amount, for the longitudinal profile, and also for the other ones. Okay, so this so far we would think it's in 20-meter offset in terms of lateral displacement. So now let's enter these values here, and number 5, and just some random values in here again, and the same for the vertical component. Okay, so again, some distance to a reference point. So the goal is actually, the clue is now that so far we only know the randomized offset amount, but once you press save button, once you have done everything, you will get out the correct values within your files here. So test example blind. Okay. Okay. Okay, saving is done. So if we go now to the correct folder, in here, let's see where it is, we can identify the actual displacement. So now blind is here, and let's see, go to the HTML maybe. Here we go. So this is the value we actually have. So from the GUI we would think it's 28 meters, but now the actual displacement value we generated, or that we measured, was 20.3 meters. I wasn't very precise in that case, but you get the point that you can do blind measurements with this approach. You can remove some of the bias that is normally existing with this type of measurement approach.